Welcome back, everybody. The topic for this lesson is non-origin centered dilations. Now, what that means is that we're going to be dilating a figure like we have done before. However, this time we're going to be going from a point that's not the origin. We're going to be going from somewhere out here. Now, there are algebraic ways of doing this, just like you can do from the origin. However, it's much more work than what we need to do for this particular class. The examples that we're going to be working with, the method of counting will be able to be used for all the examples. So we're going to just stick with the counting method for this lesson. Now, this first example tells us that we're going to be dilating triangle ABC using a scale factor of 2 from center 1, -2. So here's our triangle. The coordinates are not listed because we're not really going to be too concerned about doing any sort of multiplication for this. Again, we're going to be sticking with just the counting method. So we want to put our center down on paper, 1, -2. So let's mark our center. Now, we want this triangle to be twice the size, which also means that it's going to have twice the distance from our center. Each of these vertices are going to be twice as far away at the end of this dilation. So we're going to just stick with the counting method for this particular example. When I look at point A, if I notice, I'm going to be going up 1 and over 3. I want to double that distance. That means I want to be going up 2 and over 6. 4, 5, 6. This is the new location for A prime. And if I was to look at this particular distance, I would notice that I am going, looks like 3 blocks away in this sort of diagonal position. And again, if I do that, it's still going another 3 over in this diagonal direction. I have doubled my original distance, which is exactly what we're hoping for. So let's try it again for point B. If I count 1, 2, 3, 4, 5, 6 up, and 1, 2, 3 over, again I'm going to be doubling that, so instead I'm going to be going 12 up from my point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm going to be going 6 over, because that is what's going to be doubling my original distance. And again, we can see it. I'm going twice as far away as where I started. So here is B prime. And C, if I go 1, 2, 3, 4 up and 1 over, I want to repeat that pattern. 1, 2, 3, 4. That's going to be C prime. Okay, so again, we're just doubling the distance away from our center. The last thing that we want to do, and I've lost my ruler, here it is we want to connect our points. Okay, and you can even see it. Everything should still be on the same line. We're expanding it on the same line because we're just making the distance grow longer. It's not going to change direction at all. We're just changing the distance from our starting point. So all these should be lined up on the same exact line. And if we were to measure those lines' distances, we would notice that all that's happened is it has doubled, which is what we're hoping for. Okay, so I have another problem down here. If you want to take a second to copy it down, if you have some graph paper. If not, maybe try even just using a piece of regular line paper and doing it as neatly as you can. This particular example has a scale factor of 2 from a center of -6, 8, and the coordinates for QRS you can take right from the paper. So try this one on your own, pause it, and then when you're ready, resume and we'll discuss. Alright, let's see how you did. First of all, we've got to plot our center at -6, 8, -6, and +8 is right here. That's our new center. What we're looking for is we're looking to find how far away from Q we are. We're going to be going this time down 3 and to the right 1. I want to be doing this with a scale factor of 2. So I'm going to repeat that. 1, 2, 3, and 1 over is going to put Q prime. R is down 1 and over 2, so I'm going to repeat that pattern. Down 1 over 2. That puts R prime. And S is down 1 over 4, so I'm going to go down 1, 1, 2, 3, 4 more to put S prime. All I need to do is connect my points. And there's my new triangle after the scale factor. Again, you can see that it should be getting larger because we have a scale factor greater than 1, so it should be enlarging. And the distances from our center are getting greater. They're getting twice the distance because we're using a scale factor of 2. Now it's also possible to do these as reductions. This next example, you notice that we're dilating triangle DEF using a scale factor of 1/3. So 1/3 means that we should be getting smaller. Our center this time is going to be from 7, -4. So first of all, let's plot 7, -4. It's right here. That's our center. Now, all that's going to be happening is our shape is going to get closer to our point. It's going to be following the same path that it would be from where it is right now. Just like when we dilated it, it was expanding along a line. Here we're still expanding. I'm sorry, we're not expanding. We're getting closer to it, but we're going to be on the same line. So we want to be moving towards our point. Well, we should notice that we are going to be 1/3 the distance from this point of what we originally were. So we're going to just count like normal. Let's count to F right now. We're 1, 2, 3, 4, 5, 6 up and 3 over. 6 and 3. We only want to do 1/3 of that. So if we were to divide each of these by 3, it's going to tell us exactly how far away we want to go. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. So I really want to only go 2 up and 1 over. And you'll notice that I'm still falling on top of the line that I had expected to. And that distance is only 1/3 of the original distance. So this is F prime. E, I'm going up 6, but instead I'm going over 9. So I only want to go 1/3. I'm going to divide 9 by 3. That'll give me the length of 3. So I want to go up 2 and over 3 for F. I'm sorry, E. I'm getting all these letters mixed up. Alright, and last we have D. D, we go up 1, 2, 3, and we're going over, again, 9. So instead of going up 3, I'm only going to go up 1, and I'm going to go over 3. That's going to put D prime right there. Let's connect all of our points. Here's our new triangle. It is 1/3 the size on all sides of our original triangle. I may have messed up the names of the letters. I definitely did it correctly though. Alright, here's one for you to try on your own. Again, take a second to copy this down. Hopefully you have some graph paper to work with. Our scale factor for this problem is 1/2, so again we should be getting smaller. We should be half the distance away from our center, which is at -1, -6. So try that, pause the video, see how you do in a minute. Alright, let's see how you did. We're going to put down center -1, -6. That's right here. Okay, now you don't have to draw in these lines. I'm only going to draw them in for this video, in fact, because I want to make sure that we can see exactly what's happening. I want you to be able to see that the distance is being cut in half, but it's still going to be along that same path line. So here we go. Here's the path of distance to all those points. If I check how far away point T is, we're 1, 6, 10 up and 4 over. So we went 4, 10, but we only want to do half that distance, so I'm going to end up going only 5 up and 2 over from my original point. 1, 2, 3, 4, 5, 1, 2. Okay, there's my point T prime. When I look at U, is only 6 over, I'm sorry, up and 2 over, so I want to do half that, so 3 up and 1 over. That's going to point U. And lastly, V is 10 up and 4 over, so I want to go 5 up and 2 over. That puts point V right here. So again, all we're doing is just figuring out how far away we are to begin with and cutting that distance in half. And that is what our new triangle TUV is going to look like. Hopefully you did okay with this. I know I messed up on a couple of things that I said. I hope that didn't confuse anybody. But again, we're just going to be following this kind of trajectory path where we're going to be cutting it in half instead of making it longer. But it's still going to be along the same line. Alright, if you have any questions, let me know in class, or you can even leave some comments on the website, and maybe I can clear those up for you.